learning? Okay, we're going to learn about the law of cosines. So the law of cosines is used if you know a side, then an angle, and a side of a triangle, or if you know three sides of a triangle. Okay? So for side, angle, side, or side, side, side. For law of sines, I don't know why it's making that funny mark. We know like an angle, angle, side, angle, and a side, side angle if acute, okay? If acute. So to determine which of those two things to use, if you know two sides and an angle between the two sides, or three sides of any triangle, you combine the third side. And so this is basically what the law of cosine says. I'm going to derive it for you because I think it's kind of interesting to know where it comes from. C squared is equal to a squared plus b squared. We're almost there. What does that look like? That looks like the Pythagorean theorem. But the law of cosine says c squared is equal to a squared plus b squared minus 2ab cosine c. Okay? Who's seen the law of cosines before? Has anyone ever seen the law of cosines? So basically, if you think about the Pythagorean theorem, right? The Pythagorean theorem is for right triangles. If I have a triangle, say here's C, and here's A, and here's B, will this side be bigger? Will c squared be bigger than a squared plus b squared, or smaller than a squared plus b squared? Like if this is an obtuse triangle, this side is going to be bigger than the square of a squared plus b squared, or the square of that. If it's an acute triangle, right? Then if this is a and this is b and this is c, then c squared could be smaller than a squared plus b squared. Now it turns out if I take the cosine of an angle that's less than 90 degrees, that's a number, that's a positive number. But if I take and I would be subtracting something. But if I take the cosine of an angle that's bigger than 90 degrees, that's going to be a negative number, right? Watch. If I take the cosine, where's my calculator? Your calculator. Your calculator. I want to show you this, okay? Where's my calculator? We'll just take this calculator. Come on. You can do it. Okay, so if I were to, you'll learn about this more when you take trigonometry in a year or two, okay? But if I were to take the cosine of, say, 50 degrees, right? Anything between 0 and 90, it's always going to be a number between 0 and 1, right? But so if I look at this triangle, if this angle is less than 90, this quantity is going to be subtracting something, right? So c squared is going to be less than a squared plus b squared, right? But if I go back to my calculator and I plug in an angle that's bigger than 90, say that I take the cosine of 110 degrees or something like that, okay? And I'm going to get a negative number, okay? And if I subtract, if I subtract something if this is a negative number and I'm subtracting it, what's going to be true about the relationship between c squared and a squared plus b squared? C squared is going to be bigger than a squared plus b squared, right? So that's kind of the way that the law of cosine works. I'm going to do a couple problems in a second, but since last night I looked at, I always derived the law of cosines, but I never derived the law of cosines. So there's a derivation in the book, but it's kind of nice to know where things come from, okay? So here's a triangle. Come on. Oh, look, it's working great. And I'm going to draw in a height to that triangle where this is 90 degrees. You don't have to know how to derive it. I just think it's kind of interesting know where it comes from, okay? And this is big C, meaning the angle. This is angle A, no, not angle A, sorry. This would be angle B in this case, right? Angle B, and this would be angle A. And I'm going to call this side X over here. If this piece from here to here is X, and this from here to here is C, what can I call this? What can I call this from here to here? If this is C and this is X, then this is C minus X, right? Okay. So then, and we call this H. See this right triangle? This right triangle I could write as, by the Pythagorean theorem, C minus X squared plus H squared is equal to what squared? A squared, right? And in this right triangle here, I get that X squared plus H squared is equal to B squared, okay? Then what they do is they FOIL this out, okay? So this becomes C squared minus, you multiply this times this twice, minus 2CX plus X squared plus H squared equals A squared. And if I look over here, what's X squared plus H squared equal to? B squared, right? So I get that, see, you don't have to know this, I just want to show you where the law of cosines comes from. Minus CX squared, CX plus, I'm going to substitute B squared into this equation, right? B squared equals A squared, okay? And then what I'm going to do is I am going to bring this, okay? A squared, X squared, C squared minus 2CX plus X squared plus H squared is B squared. And I get that, oh, I'm almost there. I'm going to rewrite, I'm going to bring this over here. I'm going to say that A squared is equal to, rearrange things. I'm going to rearrange things. Is equal to B squared plus C squared minus 2CX. It's starting to look like the law of cosines. But then, what I could say is I could look over here. What is the cosine of angle A over here? If I look at this triangle, what's a cosine? What side over what side? X adjacent over hypotenuse. So the cosine of A is equal to X over B. Okay, right? Adjacent over hypotenuse. So X is equal to B cosine A, right? And then what they do is they take this and they stick it in here for X, okay? And so you end up with this formula that says, what was that? That was B cosine A. That A squared is equal to B squared plus C squared minus 2CB cosine A, which is one form of the law of cosines, okay? So law of cosine, usually they write this as BC. The law of cosine says that A squared equals B squared plus C squared minus 2 times C times B times cosine A. Or you could write this as B squared is equal to A squared plus C squared minus 2AC cosine B. Or you can write this as C squared is equal to, what? Who can tell me what goes here? A squared plus B squared, right? Minus 2AB cosine C. So the important thing to remember is this angle is always opposite this side. That goes by itself, okay? These two sides are the sides that surround B and C, are the sides of angle A. In this case, A and C, which also appear here, are the sides of angle B. And here A and B are the sides of angle C. And here's C squared and there's C. So it doesn't really matter. It's the same formula. It's just, so you don't have to worry about which is A, which is B, which is C. You have to worry about the relationship between the sides. So you ready to do? So I just thought it was kind of cool derive it so you know where it comes from. Because before I never really spent the time to derive it, but some of you guys are intellectually curious. Aren't you? Who's intellectually curious? Ryan is. Kareem is. All right. So I did want to show you that. So how do I apply this? Let me show you how to apply this. All right. And I'm going to do a couple examples, then I'm going to let you guys try a couple and see if you could get them on your own. So here is, so I'm going to draw a triangle. So log cosines is easier to set up. Well, I don't know, but a little harder to solve. So I know that this is R, and this is 45, and this is 52. Whoops, that's not 82. I know, but that's my Moby board. 52. And this over here is 36 degrees. Okay? So the way you always set it up is the side opposite the angle. So now I have a side angle side, so that I couldn't use a lot of signs, because if I try to use a lot of signs, I'd have two variables, right? I'd say sine of 36 is to R, a sine of something is to 52, so I don't have enough stuff there. So I'm gonna use a lot of cosines because it's side angle side, right? So the side opposite the angle goes by itself, okay? So R squared, and the other two sides surrounding that angle go on this side. So you do 45 squared, and it doesn't matter which one you call A and which one you call B. All you have to know is that the way you set it up is these two sides go on this side and that goes on that side. So 2 times 52 times 45 times the cosine of 36. And then this is really nice because then you could just plug it all into your calculator in one big chunk, okay? Because your calculators, most scientific calculators, are pretty good at doing the order of operations, okay? And again, make sure you are in degree mode, not in radian mode, okay? I've never used the grad mode. I guess you use that after. I don't know what that is, so you must use that after you graduate. Okay, that's not very good. All right, so okay, so I'm gonna plug all this stuff into my calculator in one big chunk. Okay, so I'm gonna go 45 squared. Where's squared? 45 squared, squared, squared. There it is. 45 squared. You have a squared button. Most of you do. Plus 52 squared minus 2 times 52 times 45 times the cosine of 36. Okay? And then I hit enter. Okay? And if I do that, I get some pretty big number. Okay, that's R squared. Whoops, where'd it go? So R squared, you always in front, always in front. We get you, can we do size? We could do a size smaller. Let's make it small. Okay? And so R squared is about equal to 942.8. Okay? Then you could leave that in your calculator. And you could just, how do I find R if I know R squared? Square root it, okay? So then I go second square root, which is above, right above square. And then you could go second answer. So you don't even have to plug, depending on what kind of calculator. That's the way I always do it. Answer is down here above the negative sign in my calculator. And then it will just plug 942.8 into it. And you get R is about equal to 30.7, whatever the units happen to be. Okay? Yes? Okay, so then I know R is about 30.7. All right. Then if you want to finish solving the triangle, then say I wanted to know this. You could use law of sines. You could say sine of b is to 45, a sine of 36 is to 30.7. and find b, right? And then you could go, if it's an acute triangle, because if you have an obtuse angle, you might run into problems there. Okay, but most of your problems will be all acute triangles if they're asking you to find the other angles. All right. So let's try. You try one like this, and then we'll do one where you just have to find the angles. Okay. So you guys try. See if you could do it. You try. You try. You try. I'll draw a triangle for you. Let's make this angle 47 degrees. 47 degrees, 13, 10, and C. Find C. Find C. Go ahead. Give that a shot. Everyone, try. Gotta try. Yeah. It's there. I know, yeah, but I gotta finish teaching you, okay? Annette's not here. She's taking another class. Oh, the nets. I get it. Okay, say I have something that looks like this. And, hey, look, it made a triangle again. So I know that this side is 200. Oops. This side is 225, okay? And this side is 175, even though it doesn't look like it. And this side is 250. 250, okay? 250. That says 250. 250. 250. Okay? And I'm going to call this find Q. This is Q over here. Okay? So if I'm setting this up, this one, it's a little more tricky when you're trying to find an angle. So here's the angle you're looking for. So that's going to go over on the right side of my equation. This is going to go on the left side of my equation. Okay? So the way I set it up is I go 250 squared equals the two sides surrounding that angle, 175 squared, plus 225 squared, minus 2 times, again, these two sides, 175 times 225 times, I'm going to move over a little bit, whoops, get out of the way, calculator, times the cosine of Q. You guys see how I set that up? So this, you got to be a little bit careful, because what people always do, and this is what a lot of you are going to make this mistake, they combine all this stuff together, the 175 squared, the 225, minus 2 times this times 2 times that. You can't do that because you're violating the order of operations. So first you have to square the 250 and subtract these two. So you're going to go 250 squared minus 175 squared minus 225 squared, and then you're going to get some number. Let's just do that, okay? So you get, let's see, 250 squared, is that squared? Yep. Minus, is that minus? I think so. 175, I need my glasses, squared, minus 225 squared. And if I do that, I get negative big number, negative 18750, okay? But negative 18570 is equal to negative 2 times 175 times 225 times the cosine of Q, right? So now what do I do? How do I get cosine of Q by itself? You have to divide everything on here into here, right? So I'm going to divide, different color. Let's do this color, okay? So now I'm going to divide both sides by negative 2 times 175 times 225. Okay? And I'm going to divide that side by the same thing, right? Negative 2 times 175 times 225. And again, here you have to be careful or you're going to make mistakes, okay? You have to put this all in one chunk that you're dividing by, right? Otherwise, it's going to divide by negative 2, then multiply by 125 and 185. So when I put this into my calculator, I'm going to take this number, I'm going to go divided by, in parentheses, okay? In parentheses, negative 2 times, can't see, negative 2 times 125 times 2. Oh, is that 175? Sorry. Thank you. Oops. 175 times 225. Close that parentheses, and then I'm going to hit enter, and I get a decimal answer, okay? That should be a 7. And that's good because that means that the cosine of q over here by itself is equal to about 0.2380, right? And if that's a negative number, that's okay. That just means you're going to get an angle bigger than 180. This looks like it's going to be bigger than 90. So how do I find out what q is if I know that this is it? If the cosine of q is 0.238, yes? Then you do the second, okay? So that's where I go second cosine, second answer, okay? And I get out about 76.22 degrees, okay? If you get an error or something, you know you did something wrong, okay? So this is approximately equal to 76.22 degrees. Yes? No? And then if I want to find this angle, I would have to, I guess I could use law of sines. Unless it's an obtuse angle, then you can't use law of sines, which it looks like this, you have to use law of cosines again, okay? So if it's an obtuse angle, then you would have to use law of cosines again, because because law of sines will not give you the value of that obtuse angle, okay? So that's about that. You ready to try one? Who wants to try one? Yeah, well, you're going to try one anyway. Okay, so here we go. You try. You try. Where's my you try? I made some bad numbers, but it's going to work. Okay, so this side is called it. Ooh, I like that color. So let's call this side 100. And I should have units on there. I'm just ignoring the units for right now. 93. Find angle B. Okay. Find angle B. Okay. Give that a shot. So wait. I have to show the studio audience what the answer was. The answer for the studio audience was, what was the answer? 79.7 degrees. So B comes out to be 79.7 for those of you out there in TV world. Okay.